Hello guys, good morning. Welcome to my channel. So today I'm here with the class 7 of the computer aptitude with respect to the logic gates. So this is mainly for the National Housing Bank examination, which will be most probably held in the next month, that is the last week of February or in the first week of March. Okay, so in yesterday's class I have already discussed the basic logic gates and their truth table and the formula and also the symbols. So these were the basic. So if you are strong with the basic, then this class will be very easy. And also I will show you how the questions were asked in the previous SBI PO mains and IBPS PO mains. So I have taken most of the questions from SBI and IBPS PO mains itself. So according to that, we will be solving questions, and also some of the questions are from a National Housing Bank examination itself. So without wasting any time, let us start this class. So before that, please share it with your friends so that they can also get some benefits from watching these free videos with quality content. Okay, so with that, let us start the class. So what I have done is I have taken this in the form of a MCQ form. Okay, so an inverter output is the complement of its input. So inverter is nothing but negation. So if A is the signal, then for the inverter the signal would be A bar. So that is, if 0 is given, it will become 1. If 1 is given, it will become 0. It is similar to NOT gate. So the question is, an inverter output is the complement of its input. Yes, this is absolutely true. So when, as I said, when 0 is given, it will get complemented to 1. When 1 is given, it will get complemented to 0. So this was a simple easy question with respect to NOT gate. So if you know the logic of NOT gate, you can solve this question. The Boolean expression for a 3-input OR gate. So basically for OR gate, you know, this is the diagram, right? So now, and the formula is y is equals to a plus b. A and b are the two signals, that is, here it is a and this is b. So now they are asking for 3-input OR gate. So simple, just add one more signal and draw the diagram. So y is equals to a plus b plus c. See, this is very simple, right? So the answer here is b. So if you know the basic formula for the OR gate, then you can derive for any number of signals given for an OR gate. How many entries would a truth table for a 4-input NAND gate have? So see, for the basic NAND gate is this. So everyone is knowing this. So now they are asking 4 input. So for this, what can be the possible truth table? So it would be difficult for us to calculate each and everything. So the formula is 2 power n. So remember this. So for the number of entries in a truth table would be 2 power n. So they are asking for 4. So 2 power 4. It is 16. So remember this. If you know this formula, then it is just you can solve this in a pinch of seconds by looking into the question itself. There is no need to write anything. Okay. From the truth table for a 3-input NOR gate, what is the only condition of inputs A, B, C that will make the output high? So, simple. So for NOR gate, it is a 3-input. So you draw a NOR gate. So for the NOR gate, the expression is y is equals to A plus B plus C. So they have already given the signals for A, B, C. So by looking into the options, now we need to put A, B, C signal such that the output must be high. High is nothing but 1 and low is nothing but 0. So remember this. So for to make the output high, we need to select one of the options which will make for this condition high. So we know that y is equal to A plus B plus C. So in this, yeah, I'm sorry, I missed here. It is NOR gate, so we need to put a negation here. Okay, it was a slight mistake. So I wrote it for R, but for NOR we need to write a cherry here with the negation. Okay, so we need to make the output high. So what can be the exact condition? So if we put 1 1 1, then the sum will be 1, but the negation, so answer will be 0. And again in 1 plus 0 plus 0, the answer is 1. So if the negation of 1 is 0, and again 0 plus 0 plus 1, negation of 1 is 0. So but here 0 plus 0 plus 0 and negation of 0 is 1. So this is the correct answer. Okay, I guess you understood. So I'll explain you once more. So for a 3 input NOR gate, the formula is A plus B plus C negation. So we need to make such that choose an option such that the output is high. High means 1. So if we put A equal to 1, B equal to C equal to 1, then yes, the answer will be 1, but the negation is present. So negation of 1 is 0. The same procedure applies for first 3, but the fourth one, 0 plus 0 plus 0, negation of 0 is 1. So the answer would be 4. So by using the fourth option, we can make the output as high, that is 1 for the given condition. So like this, you need to derive. Which of the following is not a basic Boolean operation? So the answer is forget. So there is nothing like forget. So the answer would be 4. This is very simple question. Okay, this was taken from SBI PO mains itself of 2015. Which of the following calculation would accurately describe a 4-pin OR gate? Okay, so they are asking about OR gate. Okay, so now they've also given this signal. This is 1A 1 0 0. So they're asking what will be the exact thing and the output. So you they've already given that it should be addition. So the formula is also has also been provided. So A plus B plus C plus D. So this is the formula. Okay, they have provided everything, 1 plus 1 plus 0 plus 0. Okay, so we need to find the exact option by looking into the output. So what can be the output? So if we keep on adding 1 1 0 0, so if we add, the answer should be 1, not 0 1. So the answer here is B. So don't get confused with A and B. Here it is 0 1, here it is 1. So you should not write as 0 1. Though it may be logically correct, but we need to only represent it with 1. Okay, remember this. These kind of questions will confuse you. Okay, and this question was from IBPS PO. IBPS mains of 2016, I guess. You can check the paper also. So this was from IBPS. See, the questions are simple, but they are quite tricky. So the output of an XOR gate is high only when. So in yesterday's class, I had taught you the logic for XOR gate. Okay, and if you don't remember the truth table also, if you remember the formula for this XOR gate, then you can say when the output will be high. So now let us see how can we derive that. So the logic for XOR gate is y is equals to A bar B plus A B bar. So this is the logic. Now we need to find when 0 0 0 1 1 0 1 1. So when this logic is given, in which of the following cases the output will be high, that is 1. So in one of the cases it is high. So let us see from which case. So in the first case, if I provide 0 here, it will become 1. If I provide 0, it will become 0. 0 into 0 is 0. And in the for the second term, if I provide 0 here and 0 here, so 0 into 0 0. So here 0. So it can't be equal. So both inputs can't be 0. So you can eliminate this. Okay, both inputs are undefined. You can also eliminate this. Now there are two choices. So we need to check for these two choices. Okay, now let us check for these two choices. Okay, for 0 and 1. So if I provide 0 here and 1 here, so 0 bar is 1, 1 into 1 will be 1. And again if I provide 0 here and it would be 0. Oh, so 1 plus 0 is 1. So see, you got the answer here itself. When when both of the inputs are unequal, then the input output will be high. Let us also check for this 1 and 0. So if I provide 1 here, it will become 0. But if I provide 1 here, so 1 into 1 will be 1. So this is also 1 correct. So the answer here would be the two inputs are unequal. So this is a very important question. So it was a question of NHB itself. Okay. So this question from this question is from NHB. See, the question looks a bit difficult for you all, but if you try to solve them, it is very simple. So if you know the basic logics with respect to the yesterday's class, then you can surely solve this question. Okay, now let us go into the next question. When does the output of a NOR gate equal to 0? So the NOR gate is this. So and the logic is y is equals to a plus b. So 0 0 0 1 1 0 1 1. So when does the logic of the NOR gate become 0? So only in this case when both of them are 0, only when all the inputs are 0. See, I took almost at least I took just 10 seconds to solve this question. So if you are so quick enough, then you can use the remaining time for other questions, solving other questions. Okay, when does the output of a NAND gate equal to 1? So the logic is y is equals to AB, a into b, negation of a into b because it is an AND. Okay, 0 0 0 1 1 0 1 1, simple. So now 0 into 0 is 0, 0 negation is 1, 0 into 1 0 into 1 is 0, 0 negation is 1, 1 into 0 is 0, 0 negation is 1, 1 into 1 is 1, 1 negation is 0. So they're asking when it will be 1. So in all these three conditions, so let us check the options. When a 0 is present at the input, yeah, this is the exact thing. So remember that whenever a 0 is present at an input, then the output will be 1. So you may also remember by heart these things, but by hearting will make you confused in the examination and will lead you to mark a wrong answer. So instead of that, learn this logic. So try to write a Boolean table, then you can solve the questions. Which of the following is a logical conjunction? So it is AND gate. Okay, if A and B are two input ends of AND logic gate and A and AB is the only input. So see, this is a this question looks this also from IBPS PO mains. Okay, see, this question looks complicated, but this is one of the easiest question. So they have provided AND gate. So draw an AND gate because they are told two input AND gate. Okay, and the only output. So this is A, this is B, and this is AB. So they are saying that what will be the output if the input is 1 and 0. So for the logic the logic of AND gate is AB, they have only provided. So 1 into 0 is 0, so the answer is 0. See, very simple question. The thing is, you need to know the logic. The question though may seem very difficult, but it is one of the easiest questions. Okay, so these were the total questions, guys. I almost referred almost 3 to 4 years of banking examination papers and brought this video for you all. So if you like the video, please like it and share with your friends and subscribe to my channel. So I'll be getting more number of videos for this examination. So from that you can ace your examination. So in the next class I'll bring more questions on this logic gates, so which can fetch you easily 5 marks. Okay, so that's all for today, guys. Thank you.